Okay, folks, so today is our second look at section 3.3, which is on estimating square roots of non-perfect squares. So we looked at this a bit yesterday. We used number lines to estimate, and we said that we wanted to be within 1/10. We wanted to make estimates in the 10th place is our goal in this section. Okay, so we're going to look at some examples again here today. So this picture here shows 3 tatami mats that are used in judo. And the area of the green mat is 36 meters squares. And the area of the purple mat is 49 meters squares. And can you think of how we might figure out an estimate for the side length of this red mat? We can pause the video here if you need time to think. Okay, so what I'm hoping you're thinking today is if the area of this green mat is 36, then that means the square root of 36 is 6. So that means the side length of this green mat is 6 meters. And the side length of this purple mat would be 7 meters. So the side length of this red mat would be 6 point something meters. Maybe it's 6.5 meters. Okay, but we know for sure it's going to be somewhere between 6 and 7 meters. Okay, that's kind of our thinking there. Somewhere between 6 and 7 meters. All right, let's look at example 1. So this is out of the grade 8 textbook, of course, because this section came from there. This page 96 of the grade 8 textbook. Felicity wants to know if a wading pool will fit in a small space in her yard. She must estimate the side length of the square wading pool, which has an area of 7 meters squared. So the area of this pool is 7 meters squared. I want to know the side length. So what I really want to know is the square root of 7. So yesterday we talked about estimating the square root of non-perfect squares, and we said we would use a number line, okay, to find that estimate. Okay, so we are finding the square root of 7, estimating. So yesterday we said to estimate, we draw a number line, and we use 2 benchmarks, which are the perfect squares that land on either side of 7. So if we look over on the wall to our tower of perfect squares, 4 and 9 are the 2 perfect squares that are on either side of 7. Okay, so the square root of 4, square root of 7 is what I'm finding. The square root of 4 is 2, and the square root of 9 is 3. So there's my number line set up, and I have to find the square root of 7. So yesterday we talked about our next step would be finding the middle. And to find the middle, you need to find the average of these 2 numbers. We need to add them together, 4 plus 9, and divide by 2. Okay, so 6.5 would be the middle of 4 and 9, and then the middle of 2 and 3 would be, of course, 2.5. Okay, I want the square root of 7. I'm getting much closer with 6.5. I would probably find the middle again, just to make a really good estimate. I know it's more than 2.5. I don't know, is it 2.6, 2.7, 2.8? Okay, we're going to find the middle again to determine that. So this would be 2.75. And then the middle of 6.5 and 9, okay, you add them together, 15.5, and divide by 2. What is that? 7.75. Okay, and I want the square root of 7. I would dare say we should find the middle one more time at least, and then I can make a really good estimate. So 6.5, I get my calculator out for this one. 6.5. Whoops. Oh, it's big. Here we go. 6.5 plus 7.75 equals, divided by 2, is 7.125. And then the middle of 2.5 and 2.75 is 2.625. Okay, so I can really make a close guesstimate now. So square root of 7 is very close to the square root of 7.1. And since it's a little bit less than 7.1, I'm going to say maybe 2.6, because 2.6 is a little bit less than 2.62. So 2.6 meters, okay, would be my estimate for the side length of that pool. Okay, it's a lot of work to estimate with a number line. Okay, but that's part of the outcome. So we do have to spend our time, okay, demonstrating our number sense. There's a lot of, knowledge that you must have to be able to do a question like that, which is good. So my answer for A is 2.6 meters. B, use a calculator to approximate the side length of the pool to the nearest tenth. So again, it's 1 decimal place. So I'm going to use my calculator and I'm going to take the square root of 7. If I knew how to do that on this calculator, that would be good. There we go. 2.6. Okay, 2.64, which rounds to 2.6 meters. Compare your estimate in part A with the calculator's approximate answer. Okay, they're bang on. They're the same. Okay, so the back side of your page basically has 3 of these. Use perfect squares to estimate the square root of each of these to 1 decimal place, and check your answer with a calculator. So we are going to draw a number line for all 3 of these. So the first one I'm going to do is the square root of 18. And draw my number line. I need to pick the 2 perfect squares that are on either side of 18. Okay, so 16 and 25. The square root of 16 is 4, and the square root of 25 is 5. I therefore know the square root of 18 is 4 point something. Okay, next step, find your middle. 25 plus 16 divided by 2 is 20.5. You can use a calculator if you need to. And the middle of 4 and 5 is 4 plus 5 is 9 divided by 2. It's always the same method, or you might just know the middle is 4.5. I want the square root of 18, so I'm going to find the middle again. It's somewhere between 16 and 20, so we'll find the middle. 36.5 divided by 2 would be 18.25. And the square root of 18.25 is approximately the middle of those 2. Okay, I know the square root of 18 is a little bit less than the square root of 18.25, so I'm going to guess 4.2. Make sure your estimate is shown on the number line. Make sure it's circled and obvious. Okay, and then we're going to check with the calculator. Take the square root of 18 on your calculator. .24. Again, I'm going to round it, so 4.2. Often they will be the same. Sometimes they might be 0.1 off, but you should be pretty close. Okay, please try B yourself. You can pause this video. Try B. Okay, you might have had a chance to set it up. There's what my work would look like for this one. So my estimate on the square root of 23 would be about 4.8. Okay, 4.7, if you had that, you're a little bit too low because 4.75 is 22.75. We want 23, so you should be a little bit higher. So 4.8 should be pretty well what everyone agrees upon. 4.9, you're going to get closer to 25. So I would suggest, you know, keeping it a little lower there. And then if you plug it in your calculator, the square root of 23 is 4.7958. Okay, which is 4.8 as well. These squiggly equal signs means approximately. This usually means, you know, exact. Okay, try the last one. Okay, so you might have had a chance to try this one yourself. My work looks like this. I'm going to estimate the square root of 35, which I know is a little bit higher than the square root of 34.625. So my guess, I'm going to make my number a little bit higher than this, which I would say is, that's right, 5.9. Okay, if you want to check it on a calculator, what in the world is the square root of 35? 5.91. Okay, so the calculator or the check, 5.91. So we are pretty close. Okay, you're going to try the booklet that we hand out here in a moment. I just want to mention that, okay, in the booklet, so you're going to complete the booklet. Here, let me type this. It'll look better. So complete full booklet. For question number 4, please draw number lines. It's the only one that you have to draw number lines to approximate the answer to the nearest tenth. Okay, so question number 4, there's little tiny blanks at the bottom, number lines. You can draw number lines there. Okay, it's the only question like that. Great. Okay, happy practicing.